Morning chemistry class. This is Hugh again, May 12th, Tuesday, and today our topic is percent actual theoretical yield assignment. So just the original thing is the formula for percentage yield. It's the amount that you actually get, the actual yield, divided by the amount, the most you could have possibly gotten, the theoretical yield. That times 100 is percent yield. And then the other equation that you have to know is that the amount in moles is always the mass in grams divided by molecular. Okay, so this refers to the assignment that's posted on Google Classroom, and I'm going to do two worked examples, and then there'll be three questions that you have to do on the assignment. All right, so let's take a look. I've got my periodic table handy. Sample question number one involves lithium hydroxide plus potassium chloride reacting to form lithium chloride and potassium hydroxide. It is, of course, a double displacement reaction. And what they say is that you have a mass of 20 grams of lithium hydroxide, and you're asked to determine the yield of lithium chloride, or how much lithium chloride we're going to make. Okay. So we start with the first step will be we have a mass of lithium hydroxide. Whenever we have a mass, and we can always find the molar mass from the table, we can determine the amount in moles. So step number one is to find the molar mass of lithium hydroxide, and then you do it like this. So I'll use two capital M's for molar mass. There's lithium, there's an oxygen, there's a hydrogen, and lithium from my table, so right here, is 6.94, and that's grams per mole. Oxygen on this table is 16.0, and hydrogen is 1.01. So those numbers come directly from the periodic table. If you don't have one on paper, you can just get one online. There's lots and lots and lots of them. You add them up because there's one of each of those atoms, and I got 23.94 grams. And that's grams for every mole. And the next step now will be to find the amount, I'll use the abbreviation AMT, the amount of lithium hydroxide, and that will equal the mass divided by the molecular mass. So 20.0 over 23.94. Units are optional at this point, but grams and grams per mole. And then when you divide it, my calculator gave me 0.835 mole. Mole could be written MOL or MOLE, it's your option, depending. So that's the first part. Now we know how much lithium hydroxide we had in moles. The next part, we have to refer to the equation. In this equation, it's a simple one. I'll put ones in. There's no numbers except one. Everything's a one. So one lithium hydroxide reacts with one potassium chloride to make one lithium chloride and one potassium hydroxide. But you could equally well say 1 mole of lithium hydroxide reacts with 1 mole of potassium chloride to make 1 mole of lithium chloride and 1 mole of potassium hydroxide. And that would mean then 0.835 moles of lithium hydroxide would produce the exact same amount of lithium chloride. So there we can say amount lithium chloride will equal the same number. But that's only because it's a one-to-one reaction. In the next example, I'll show you where you have to consider the fact that usually it's not a one-to-one reaction. And now we have the amount of lithium chloride, and we want to find the mass, the theoretical mass that can be produced. We go back to this equation. Amount is mass over molecular mass. So the mass of lithium chloride equals amount multiplied by molecular mass. And that's just a rearrangement of that equation. The amount, 835. And now we need the molecular mass of lithium chloride. So again, off to the side, I go lithium and chlorine. There's only two atoms involved. Lithium is the same, 6.94. Chlorine from my table, 35.45. Add together, and you get 42.39. units or grams per mole. So then that goes in here. And when I multiply it, the answer I get is 35.40, rounded, and that's in grams. And that then is called the theoretical yield. The last part of the question asks for the percent yield, and I sort of run out of space, so I'm going to cram it in here. So by my highlighter, oops. If the theoretical yield is 35.4 grams, the actual yield 6 grams. So it was not a particularly good yield. That's okay, that happens. It's still the same as the equation, use the equation there. Actual yield divided by theoretical yield times 100. So the percent yield will equal 6.0 divided by 35.4 times 100. And if you put that in the calculator, I got I think 17%. I'm just looking, let's look that out now. 6.0 divided by 35.4 times 100. And that's 16.9. You just say 17%. 17% yield. That's the first question. The second question, number 2, involves a hydrocarbon combustion reaction. It's been balanced for you. C3H8, which is propane, plus 5 O2s make 3 CO2s and 4 H2Os. And they say if you start with 5 grams of C3H8, what is the amount of water that you make? And notice that there's 2 products. They ask for water. If they asked for carbon dioxide, we'd work it out differently. So it just depends on the question. So they want to know what's the theoretical yield of water if this was all to completely combust. So our method will, since we know 5 grams of this, we're going to use the amount is mass over molecular mass. So we need the molecular mass of propane, C3H8. So we start with molecular mass, mm. It'll be 3 times 12 point, my table says 12.01, plus 8 times 1.01. And those numbers, again, come from your periodic table. They are the atomic masses of carbon, 3 carbons, 8 hydrogens. And when you add them up, 36.03 and 8.08, I get a total amount, when you add them together, of 44.11 grams per mole. That's the molecular mass of this compound. So our first step, this will be step number 1, I suppose. Second step, let's find the amount, AMT, of the carbon compound. Amount is mass divided by molecular mass, so 5.0 divided by 44.11. And when you work it out, it should be 0.113 mole. Now this is mole of C3H8. Now this is where it gets interesting because unlike the other equation, there's a 1 here. For every 1 C3H8, it reacts with 5 O2s to make 3 CO2s and 4 H2Os. It really doesn't matter how much of these there are. In this question, they only want to know about water. And what this is saying is that for every 1 molecule of C3H8, it produces 4 molecules of water. Or 1 mole of C3H8 will produce 4 moles of water. Or whatever number of moles of this you have, it's 4 times as much water. That is, every time it reacts, for every 1 of these, you make 4 of those. So now, because we can see this, our next step is simply to find the amount of water. The amount of water is determined by the equation and how much of this you have. So if it's going to be 0.113 mole C3H8. 8 times 4, because there's 4 moles of water per mole of C3H8. And when you multiply it, you get 0.453. And that'll be moles of water. Next, since we know moles, the amount, we can always find, step 4 would be to find the mass of water. We'll need the molecular mass, of course. And from the table, and you probably have seen me do this enough times, oxygen 16, hydrogen 1 is going to be 2 times 1.01. So when you work it out, from my table, I got 18.02. That's the molecular mass. So now to find the mass of water, mass is a molecular mass times amount, so 0.453 mole times 18.02 gram per mole, and that'll equal 8.16 grams. Okay. The last part of this equation, or this question, is a little different. I'll highlight it over here. It says it a little bit backwards. It says, if the percent yield is 75, how much water was made? Well, it's the same equation, but we're putting in a different numbering. So I'm going to do it on another page. But remember, 8.16 here is the theoretical yield. It's the most water that could have been made if the reaction went to completion. We know the percent yield is only 75, so the actual yield's got to be smaller than this. In fact, if you think about it, it's 3/4 the size of that. Okay, I'm back. Percent yield is 75%. Our actual yield is X, the unknown, and the theoretical yield, 8.16 grams. Putting into the equation, we have 75 equals X divided by 8.16 times 100. Excuse me. What you do is first you divide each side by 100 to move that 100 over. So you have 0.75 equals X over 8.16. Your different choices here, but sometimes people like cross multiplication. All numbers are fractions, so 0.75 is 0.75 over 1. Cross multiplication just means that whenever you have a fraction equals a fraction, it's always true that the top times the bottom equals the top times the bottom. So it's a little x. That's called cross. So therefore, 1 times x, x equals 0.75 times 8.16, which would give you 6.12 grams of water. And that is the actual yield. I hope this helped. Please take the time now to go through the extra questions and hand them in, and make sure you understand how to do this topic. We'll be meeting again on Thursday to do the next part